Hello dear friends, myself Shalendra Bora, and today I will discuss some brief concepts of the projectile motion. So before starting projectile motion directly, we will discuss what is projectile motion and what are the uh, basic fundamental requirements needed for the projectile motion which we are going to discuss today, and what is the meaning of the projectiles. So let us start, and this is a very simple topic, and first we will know about the meaning of the projectile motion. Actually, the projectile motion is a motion of a particle in which a particle moves under the effect of only gravitation force. Suppose if we throw a ball from the ground, this is the ground, this x axis is representing ground, and we throw a ball from the ground and it moves in this path, in this way, and if there is only gravitation force acting on it, only gravitation force is acting on the particle during the complete motion, then this is known as projectile motion. Now, what is projectile? Projectile is the particle, this particle which is traveling in this trajectory, this particle is known as projectile. So the projectile motion is a two-dimensional motion. We know that in a straight line motion there is one dimension motion, and projectile motion is a two-dimensional motion because its motion is curved. Now, before deriving its equation, let us discuss what are the main points which are to be followed during the projectile motion. The first point which we have to keep in our mind is that the air resistance force during the projectile motion should be taken zero. Practically, it is not possible to keep air resistance zero, although it is negligible for an object, but we are deriving the equation. In this equation we will follow that air resistance force is zero. Second, the value of gravitation acceleration value of gravitation acceleration value of the gravitation acceleration small g is constant during the motion. Value of the gravitation acceleration small g, its value is taken 9.8, we know that, and its value during the whole projectile motion is kept constant. So the motion, during that motion the value of g will not change, so it is the main point, we have to take it constant. Third point, curvature of the earth is neglected. Curvature of earth is neglected. This is another important concept which we have to keep in our mind. We know that earth is a spherical and it has some curvature, but during the projectile motion we are following that the surface of earth is always going to be flat. We are not going to consider it as a curved body. Okay, so we have to take it as a flat body. Now, next point is that effect of earth rotation is also neglected. Effect of rotation of earth is also neglected. Rotation of earth is neglected. We know that earth revolves on its axis. And it has some angular velocity and linear velocity. So whenever we throw a projectile, the projectile will get some relative velocity due to the earth motion. So we are going to we are going to consider it negligible, and we are not going to consider during the motion this projectile. Now, what can be the example of the projectile motion? So let us discuss some of these example. When a ball is hit by a bat, then ball goes in the air, and during that motion the ball is known as a projectile motion. Similarly, if a ball is dropped from a high tower, or a food packet is dropped from a aeroplane, then its motion is known as projectile motion. So there can be many projectile motion. Now, before deriving the equations, we are going to classify the projectile motion. The projectile motion can be classified into three parts. These are the three parts by which the projectile motion can be classified. So, first one is the oblique projectile motion. Oblique projectile motion is that projectile motion. Oblique projectile motion is that projectile motion in which ball is thrown at an angle theta from the surface of the earth. Here the ball is projected at an angle theta from the surface of earth, therefore it is known as oblique projectile motion. Second one is the horizontal projectile motion. In the horizontal projectile motion, normally the projectile is projected at a certain height. So if we climb up on a tower, on a cliff, suppose that this is a tower, and we are going to throw a ball horizontally from the top of the tower, then its motion will be like this. So this motion is known as horizontal projectile motion. And the third part is known as inclined projectile motion. Now, what is inclined projectile motion? In the inclined projectile motion, a ball is thrown on an inclined plane. The ball is thrown on an inclined plane, so this is known as the inclined projectile motion. All these projectile motion have some basic equal properties. There are some basic equal properties which are to be followed for doing the questions of the projectile motion. So now we start the oblique projectile motion. So before starting directly the equations of the projectile motion, now let us discuss what are the basic fundamentals which we have to keep in our mind during the oblique projectile motion. So this is taken as x-axis, and this is representing the ground level. This is taken as y-axis, and a projectile particle is thrown from the ground. So this is the trajectory of the projectile. Trajectory is the path through which the projectile move in the air. So this is the trajectory of the projectile motion. The initial velocity of the projectile is considered as u. U is going to be taken as the initial velocity. The angle of initial velocity from x-axis is taken theta. Sometime in the question, theta angle, we are given that 30-degree angle from the vertical. This y-axis is taken as a vertical. So if we are giving the 30-degree angle from the vertical, then the theta will be 60 degree, because 90 minus 30 is going to be theta. So this point you have to keep in your mind, that theta is the angle of the velocity which is made from the x-axis. So theta is the angle which is made from the x-axis. So this velocity will have two components. This component in the x direction is represented ux, and the component of the velocity in the y direction is known as uy. Ux is u cos theta, and if we represent in the vector form, then it will be u cos theta I cap, and uy is u sin theta j cap. So these are the two components. Now, what are the effect of these components, and what are the roles of these components which we have to consider? We have a clear image of these components in our mind. This ux component is going to drag this projectile in the x direction. This projectile have a two type of motion. It is traveling in the x direction as well it is traveling in the y direction. During the half motion it is going upward, and during the next half motion it is going downward. So we have to keep in our mind that there are two type of motion in the projectile. First one in the x direction and other one is in the y direction. The ux component is going to drag projectile in the x direction, and uy component is going to give it a velocity in the y direction. So this is a basic thing which we should know about the projectile motion.